Take one of the deadliest strikes in the animal kingdom and hide it inside a creature the size of your finger. Now demand that this creature solve for separate engineering problems to make that strike work, problems that human engineers, with laboratories and supercomputers, still struggle with today. It needs a way to move faster than muscle allows. It needs a weapon that won't shatter when it delivers that force. It needs to survive the violent physics its own strike creates. And it needs to see its target and aim all in a few thousandths of a second. One small reef animal solved all four, not approximately. Elegantly, with mechanisms so refined that scientists are reverse engineering them right now to build better technology. This is the mantis shrimp, and on this channel our belief is simple: the machinery is always more beautiful than the myth. So today we open this animal up and look at the four machines inside it, one at a time. This is nature's finest. Let's get engineering. Machine 1, the spring-and-latch. How you move faster than muscle, start with the core problem, because it's a genuine limit of biology. Muscle is powerful, but it's slow. It contracts at a certain speed and no faster, which puts a hard ceiling on how quickly any animal can move a limb using muscle alone. For most creatures, that ceiling is fine. For the mantis shrimp's strike, it's nowhere near fast enough. So the mantis shrimp doesn't power its punch with muscle directly, it uses muscle to load a spring. Inside its striking limb is a saddle-shaped spring-like structure. The animal slowly contracts its muscles to compress that spring, storing energy, and then locks it in place with a natural latch, like drawing a bow and holding it. When the latch releases, all that stored energy discharges at once, far faster than muscle could ever move on its own. This is called a power-amplified mechanism, and it's the exact principle of a crossbow or a mousetrap: load slowly, release instantly. The genius is in the decoupling, separating the slow storing of energy from the instant of release. It's one of the most elegant solutions in all of biology, and the mantis shrimp wields it better than almost anything alive. The result, a limb that accelerates through water at speeds compared to a fired bullet, reaching the target in around 3,000ths of a second. Machine 1 turns slow muscle into an explosion. Machine 2, the cavitation weapon. Hitting twice with one blow, here's where the engineering becomes almost unfair to the prey. The strike is so fast that it triggers a phenomenon called cavitation. When the club moves through water that quickly, it drops the pressure behind it so sharply that the water briefly vaporizes, forming tiny bubbles in near vacuum. A fraction of a second later, those bubbles collapse, and when they do, they release a violent burst of energy, force, heat, and even a faint flash of light. So the mantis shrimp's single strike is actually two weapons. First, the physical club smashes the target. Then an instant later, the collapsing cavitation bubble hits it again with a shockwave. Two blows, one punch, even prey that survives the first is caught by the second. This is why an animal this small can shatter shells engineered by evolution to be unbreakable. It's not relying on brute force alone, it's weaponizing the physics of water itself. Machine 2 is a shockwave generator the animal builds for free every time it strikes. Machine 3, the Unbreakable club. Surviving your own violence. Now the problem that should, by rights, defeat the whole design. If you throw a punch powerful enough to boil water and generate shockwaves, what happens to your fist? It should shatter any material, taking that repeated extreme impact should crack and fail within a few blows. Yet a mantis shrimp strikes thousands of times without breaking its weapon. How? The answer is in the microscopic architecture of the club. It's built from layers arranged in a specialized spiraling, staggered pattern, each layer rotated slightly from the one beneath it. This structure is a crack's worst nightmare. When a fracture tries to form and spread, the twisting, layered arrangement redirects and dissipates its energy, stopping any single crack from racing through and splitting the weapon. The damage gets absorbed and scattered instead of concentrated. It's a masterclass in impact-resistant design, and it's Machine 3, a self-protecting weapon that survives the catastrophic forces it dishes out. This is the machine human engineers most want to copy, and we'll come back to why. Machine 4, the alien eyes. Aiming in an instant, a weapon this fast is useless without a targeting system to match, and the mantis shrimp's eyes are as extreme as its strike. They sit on independently swiveling stalks, giving a huge field of view, and each eye can gauge depth on its own without needing the other. Unlike our two-eye system, then there's the color machinery. Where humans have 3 types of color receptor, some mantis shrimp have around 16 types of photoreceptor and can detect ultraviolet and polarized light, forms of light entirely invisible to us. But here's the elegant engineering twist, and it's counterintuitive. Those 16 receptors don't seem to give richer color vision. Instead, research suggests the design is built for speed, rather than having the brain laboriously compare signals to identify a color. Each receptor reports its own channel directly, allowing near-instant color recognition with minimal processing. It's a targeting system optimized not for beauty, but for the split-second speed a strike like this demands. Machine 4 is a high-speed aiming computer, tuned for reaction time over resolution. Now, the honest caveats, because nature's finest never sells mystery as magic. The famous mantis shrimp sees millions of colors. We can't claim is, as Machine 4 shows, more myth than reality. The truth is subtler and, frankly, more interesting. It's a speed-optimized system, not a super rainbow. And while these 4 machines are genuinely remarkable, this is still a small predator with a specialized toolkit for cracking prey and defending its burrow, not an invincible ocean weapon. But here's why the machinery matters beyond the animal. Machine 3, the Unbreakable Club, is being actively studied by materials scientists as a blueprint for tougher, more impact-resistant materials, potentially better body armor, more durable vehicle and aircraft panels, and advanced protective gear. And the strike mechanics inform robotics and engineering wherever fast, powerful, repeatable movements are needed. This isn't a curiosity in a tank. It's a working set of solutions, evolved over millions of years, that our engineers are only now learning to imitate. Here's where I'll leave you. We give our admiration to the ocean's giants. Meanwhile, one of the most sophisticated pieces of biological engineering in the entire sea is a finger-sized, jewel-colored creature in a reef crevice, running for extraordinary machines at once: a spring-loaded launcher, a shockwave generator, a self-repairing weapon, and a high-speed targeting computer, all integrated into a single, seamless strike for impossible machines. If this one fascinated you, the next episode opens up another small creature running machinery that seems impossible, the animal whose body appears to have switched off aging. Same lesson, different machine. That video's on your screen right now, and the full series is linked in the description below. Subscribe to Nature's Finest for the mechanisms behind the marvels every week.